Jefferson for autonomic networking use case for distributed detection.
Good morning. My name is Jefferson, and I'm going to present the draft autonomic networking use case for distributed detection of SLA violations. And this is work from other members of the team, Lisandro Granville, Alexander Clem, and Alberto Gonzalez. Next slide. So this is the outline of the presentation, and I think that it's important to say that this outline is closely related with the BOF of ANIMA working group. So we are one of the use cases for autonomic networking. So the outline shows the parts of our draft that was some kind of template from the use case for that BOF. So I'm going to start with the introduction, then the problem statement. After that, I'm going to talk about benefits of an autonomic solution, then the intended user and administrator experience for the use of our solution, the analysis of the parameters and information involved, the comparison with current solutions for the same problem, related IETF work, and some security considerations. My presentation is going to be finished with some outlook about the draft and some general considerations. So, critical network services are expected to work considering some service level agreements, some SLAs, and in order to have these SLAs, it's widely known that it's important to, in some way, to measure these SLAs. In order to measure these SLAs, it's necessary to have a monitoring infrastructure. And this monitoring infrastructure needs some kind of monitoring coverage of the network in order to capture the SLA violations. In order to do that, we can use active or passive measurement mechanisms, and considering SLA violations, active measurement mechanisms have better accuracy and privacy than passive ones, and they are also able to detect monitoring problems, network performance problems in an end-to-end fashion. In the context of the IETF, the IPPM working group has been standardizing some measurement mechanisms, and they have one-way mechanisms. So we can talk about the OWAMP, one-way active measurement protocol, and two-way mechanisms. And we can talk about the two-way active measurement protocol. And there is also a protocol from Cisco, the IP-SLA, or Cisco Service Level Assurance Protocol, which is also described in a RFC, which is not a standard, but it's defined in a public way in the IPPM. But in any measurement mechanism which are used in a network, it's necessary to distribute measurement probes on the network in order to deliver the measurement sessions and to produce the network metrics. So, previous. Yeah, thanks. And in order to do that, you have to inject traffic on the network in order to deliver these traffics. So our problem is that in order to distribute, to have these measurement probes activated in a certain location in the network, and also when you need to inject the traffic, there are some resources, some computational and network resources which are necessary to do these measurement tasks. And the required resources are a function of the number of measured destinations or the measured flows in the network. So if you have a better monitoring coverage, you need more resources, and it's usually difficult to find the sweet spot in order to have adequate coverage of the network, and also using some how can I say, some not too much in terms of the resources in the network. Besides that, when you have to monitor all connections in the network, it's usually too difficult to do because you need a lot of resources, and also you need some fast reactions when you have changes in the dynamics of the traffic of the network in order to change the configuration of your probes to capture this new state of the network. So currently the best practice is to distribute the available measurement sessions and the probes and the traffic which is injected in the network, considering the human administrator expertise. And after that, you can also use some information from the traffic matrix in order to choose which are the best spots, the hot spots in the network to perform this measurement task. So when you have some changes in the traffic matrix, you have also to change the location and also the the flows which should be measured in the network. So it's too difficult and labor intensive to have this kind of reconfiguration every time has occurs an important modification in the traffic matrix of the network. It's inefficient considering fast changing network environments, such as cloud environments and also virtual environments. And also, we still have the maximum number of detections constrained by the number of available resources for the measurement probes. Next slide. So today, the network equipment vendors, they embed management software to control measure mechanisms, and this is usually done in order to avoid problems such as starvation or inefficient operation of the device because of the resources which are being used for the measure mechanisms. And there's also a lack of scalability using these kind of mechanisms. So the resources and also the expertise are not shared among the equipment in the network. So probably the one that could share this information is the human administrator, which, as I said before, is a constrained resource in an operator or this kind of organization. So the benefits of having an autonomic solution for this problem, it's to steer the process of defining the measurement probes and the measured flows in an automatic way. And the design goals for such a solution are that this solution should be efficient, reliable, secure, and that should minimize the human intervention. In order to have a solution like this, it's necessary to have algorithms, protocols, metrics, and technologies to build a complete solution for this problem. Also talking about the benefits of an autonomic solution, there are some features that can be highlighted considering this kind of solution. The first one is that an optimization of the resource consumption and avoidance of resource starvation on the network devices. And this feature can bring some better efficiency in the measurement session activation decisions. And also it's possible to share measurement results. So this is part of my work as a PhD candidate, and we have some papers showing that it's possible to do that considering some constraints. After that, we also expect an increase on the number of detected SLA violations. So this means a better network coverage, and this in terms of the locations in the network and also in terms of timing coverage. So you can have different flows measured considering different timing in the network. Besides that, it's also expected in an autonomic solution and a decrease of the time necessary to detect SLA violations, and this is because of the adaptivity of having an algorithm to reconfigure the probes and not to wait for a human administrator to do that in a network. And also we expect a reduction on the workload of human administrators. So at least we expect that it can avoid that the human administrator needs to reconfigure the network considering all the changes in the traffic matrix. Considering the intent, user, and administration experience, as I said before, an autonomic solution should avoid the need for a high expertise from the human administrator in the reconfiguration of the probes, and this can lead to have this kind of monitoring task in a network performed by less experienced human administrators. Also, some information still will be needed from the human administration. For example, the service level objectives regarding the SLA, which is being monitored in a network. So this is information that is still needed from the human administrator. And also, we expect that the configuration and the bootstrapping of network devices for the measured process can be performed by the algorithm, the autonomic algorithm. So it's necessary some information about the address of a solution-enabled device, a solution which is already been in the overlay of the measurement task. And also after that, after knowing one device in this device in the solution, it's possible to share the information for the configuration from this device. So we expect some exchange of configuration data among the devices themselves. And as I'm explaining the solution in an abstract way, but we have some results and some software considering each of these points. So we also performed an analysis of the parameters and information involved. So first, it's necessary to have some device-based self-knowledge and decision as an autonomic solution. For example, each device can need to store the SLO, the historical measurement, considering our approach, and also the decision on how to, on each location the network and flow which needs to be measured can be performed in a distributed way considering the network. There are some solutions that consider centralized and control, for example, using an SDN controller. But in this case, we suppose that it's better to have a distributed approach for this task. Also, we consider the interaction with different devices in the network, and the devices should and can share information about the network itself, for example, about the topology of the network and the flows which are interesting to be measured in the network. So in order to have this sharing, it's important to assure that the devices which are communicating have some, for example, some properties which enable the sharing of information among them. For example, the operating system or the neighbors or the AS features and this kind of stuff. And after that, considering this information, it's possible to create an overlay, especially for the perform of measurement tasks. There are different approaches for topology definition. So in my PhD thesis, we work with peer-to-peer approach to do that. So we call that the correlated peers, and we consider as a bootstrap information to initiate the overlay, the known endpoints neighbors as the initial seed. But there are other ways to do that. There are some works which consider a different kind of a decentralized autonomic infrastructure. For example, considering an event service communication plane, and there are other words that consider a centralized plane, considering just signaling information to initiate the devices. So considering other solution, there's no standardized solution for the distributed autonomic detection of SLA violations. And the current solutions consider or a per node solution, or also some ad hoc scripts running in the devices. There are some proposals that considering just passive measurement mechanisms such as DCON and CSAMP, and they don't have a focus on the autonomic features on network, for example, to avoid the intervention from human administrators. There's other solutions that are just that consider just some part of the problem. For example, considering the anomalies and the flows and the measurement just for this kind of anomalies. And we also described our solution, which considers peer-to-peer technology embedded in the devices themselves in order to build the measurement overlay, and after that to start to share information about the measured locations. Next slide. Okay, so considering the related IETF work, there are some parts of the problem state and also the solution that are related to different working groups. For example, we can see it's the LMAP group, which probably an autonomic solution for the configuration of this kind of probes would be an interesting feature, especially considering screening. For example, if you have to define which are the locations in the network that are probably can violate the SLA, so a solution that could start this measurement process and to try to define at a high level which are the which are the locations which should be measured. This can be an interesting feature. We also have some relation with the IPFix, which is already been closed, but an autonomic solution for active measurement probably should be also performed and considered for passive mechanisms. For example, using flow information for the decision itself. As I said, in the best practice, a way to perform the configuration is using information from the traffic matrix, and probably this traffic matrix was known from IPFix or NetFlow, the OS flow, this kind of mechanism. Finally, we also consider some relation with the auto working group, because we consider an overlay for the measurement process, and we can do that. We can build a solution that considering some standardized way to build the overlay, for example, using the documents from the auto working group. Also considering all the items from an RFC, we also researched some security considerations, security problems considering this kind of solution. And there are some problems related to bootstrapping, and there are different groups which are working on that. We can talk about the Anima, the HomeNet, and other groups which are trying to have an integrated solution for bootstrapping new devices in an overlay, for example, for an autonomic process or for measurements or for other stuff. Also, it's important to have a secure way to exchange information in the overlay among the devices. So probably it's necessary to have some kind of signed messages or encryption in the information, because the information from the measure mechanism, and especially from active measurement mechanisms, is sensible one, and it can be used as a pre-attack process, or even to enable some attack on privacy. And we also highlight some possible attacks for this autonomic solution, which are denial of service attacks, considering, for example, that you can make that some devices in the network start to have a lot of measurement probes, and this can lead to an starvation on the device or a problem in the performance of the device. And also, some results could be forged by a device or by a device which is an attacker in the network, and this can lead to measuring some locations of the network which are not important at some time, and then start to have, for example, an attack in another part of the network. So there are this kind of attacks that are possible considering this kind of autonomic solution. Next slide. So we are, as I said before, this was one of the use cases for the BOF of Anima, for the use case for autonomic networking, and how can I say, this kind of work currently is not in the charter of Anima. So we continued working on the NMRG. Considering this draft, we presented, I think, twice or 3 times this draft. We have some information in the presentations about some changes and some modifications in the draft. We also have some direct messages considering members of the NMRG list. And we are in the 4th revision, which are just minor revisions and the updates of the reference. Considering the outlook for the draft, we just see minor revisions, so the draft is pretty much stable at this point, considering all the comments we had before. And we also want to add as a new approach to bootstrapping a device, the approach which is being described in Anima working group. So we think that we are in the timing for the working group last call, and you are asking that for the chairs. And that is it.
Thank you. Questions?
Congratulations for this very good presentation, but also for the paper. I have 2 questions, one a clarification question and one maybe a real question. I do understand and I appreciate that you put a lot of emphasis on monitoring probes. At the network level, suddenly you collect a lot of information, and it's quite a job to transport that information to a place where SLA model is and calculated, and the violations are calculated and then put back. So the question is how you dealt with the transporting the monitored information in a network, and is it something which you took into account or not? That's one question. The second, it appears to me that you apply this very interesting technique to SLA violation where actually you mean only monitoring traffic. However, a number of services are not necessarily directly linked with the traffic.
You mean like other networking metrics like latency?
Other things, for example, based on service models which exist today, there are other issues which need to be at account, which means I basically have to create probes, or at least to customize probes for specific type of services. And I was wondering if the work which you are doing will extend to this level of SLAs, different type of services. That's the second question.
Okay, thank you for the questions. For the first one question, talking about my approach, because the draft is the description of different approaches to bring a solution for this problem. But considering our work, as we are based on a peer-to-peer infrastructure, we have the scalability for exchanging the information in the network. So this is not our main focus of the research, because we're more interested in having an intelligent behavior from the probes. But using a peer-to-peer approach, we have a better scalability considering the exchange of information. It's widely known that when you have a centralized point in the network to have all the information from the measurement process, as you said before, it's kind of a bottleneck for the delivery of network metrics, and we are aware of this, and this is one of the drives for work. So I think that we are in a pretty good shape considering this kind of requirement. Considering your second question, I think it's a very interesting question, and it's a very important question, and I think that in the last IPPM working group meeting, there are some works which are trying to, how can I say, to model a way to monitor service metrics. And I think that probably this work can be extended to consider when you have a defined, because we used some network metrics such as delay and jitter and this kind of stuff. But I think that if you have a defined metric for a service application, or even for different kind of network metrics which we did not consider in our work, probably it would be extendable to this kind of stuff. So I think it's a very interesting point, and it can be extended, but we did not do that. So it's probable. to do that.
Okay, thanks. We're gonna return to this work in the last presentation because this is one of the two internet drafts that we have active in the NMRG today. So we have to take decisions on them, and so we're gonna return on that again. Sure.
Jefferson, you mentioned that one of the goals of this autonomic solution approach is to also lower the expertise required from the human operator. But since we have a more advanced mechanism, what will be the kind of expertise or skills needed in order to configure in the right way those solutions? Because you don't have to care about how you place the probes, etc. But then you have to care, if I want to have an efficient mechanism, what do I need to inject to him? I mean, the intent or this aspect of configuring the system. Do you have thought about this? Or?
In fact, this idea and also some part of my PhD work was done in conjunto with Cisco. So two of our authors, one it was a former Cisco employee, and the other is still a Cisco employee, and we compare in Cisco the information which is necessary to configure an IP SLA probe, and also to configure our prototype. And at that time, we had the idea that it's easier to configure our prototype than the IP SLA, but it's just like it's not. How can I say? We did this as an informal evaluation, so it's not a formal evaluation considering, for example, a model of human interaction with the software itself. So I think that we can say, as an anecdote way, that we are pretty close to have the difficult to configure a probe, but I cannot say that considering a formal evaluation, which can be, for example, a future work for our solution.
Relay from the Jabber room from Alexander Clem. A configuration of the system will involve a few points. What is the likelihood with which SLA violations will be detected? Autonomic system determines how much probing to do.
Well, one of the points that probably Alex is trying to show is that we are just considering in our research work as single as SLOs that can be detected by a single device. So, for example, we assume that each device in the network can detect the SLA violation by itself without the help from other devices. But this is also some parts of the work that could be extended considering our work.
Okay, we need to go to the next presentation. Thanks, Jefferson.
We are going to the list for the working group last call.
No. At the end of the session, we have a status on
okay.
Research group draft, and we have a point for this.
Thank you.
One final addition, because he was typing. I was talking faster than he was typing. The configuration knobs are higher level. What's the accuracy objective? How much resources can you spend?
So, Klaus.